Lab 3, Black Hole Lab. Using the resources provided, we will find the mass of the black hole, assuming that the net force on the system is due solely to the gravitational force of the black hole. Using VIDLE, we will visualize and extract data to find the mass of a black hole and describe the forces present in the data. In the visualization and graph setup portion of the Python program, I input the star's radius to be 3.5 e to the 10 meters and the radius of the black hole to be 1.5 e to the 10 meters. I also input the origin, the black hole, to be placed at -2 e to the 10, 1 e to the 10, and 0 meters. In this section, I input the mass of the star to be 1.98 e to the 30 kilograms, and delta t, the time interval between data points, to be 86,400 seconds. At the first data point, t equals 0. In this section, I use the information from the lecture, Forces from Motion, Mystery Motion Data to Forces, as a guide to filling in the required areas. Follow the link below if you would like to watch it on the class lectures page. In this while loop, the first half is used to find the x components of the velocity, and the second half is for the y components. I also use the same lecture as a guide for this calculation loop. Both of these first two sections are used to compute the star's changes in velocity and changes in momentum. These two lines are used to find the net force. The rest of the section is to find the F-net parallel and the F-net perpendicular. This is how I set up the program to visualize the data collected previously. When I run the program, keep in mind that the blue arrow represents F-net perpendicular, the black arrow represents F-net parallel, and the yellow arrow represents F-net. To solve for m, we use this equation. I used a print statement at the end of my calculation to give me this set of data. When I plug in all the information I have, I end up with an equation like this. With algebra, we can isolate the variable m. When we plug this into a calculator, we end up with m equals 2.49 e to the 31 kilograms. What does it mean? Discuss how F-net perpendicular, F-net parallel, and F-net are different from the change in momentum over the change in time, the change in momentum over the change in time parallel, and the change in momentum over the change in time perpendicular. These are all effects of these. The forces cause the momentum. Specifically, F-net parallel is the cause of delta p over delta t parallel, and F-net perpendicular is the cause of delta p over delta t perpendicular. Imagine the black hole whose mass you found was replaced by a different black hole but still placed in the same location. Assume the motion of the observed star remains unchanged and is affected only by the gravitational force of the new black hole. Could you tell the difference? In other words, is it possible for you to find the value for the mass of the new black hole that is different from the mass you found of the original one? No. The question assumes that none of these values change. If none of these values change, we will always end up with the same answer.